Today we're talking about zero and negative exponents. First, let's talk about zero exponents. Any non-zero number to the zero power equals 1. It might seem odd that something to the zero power is 1, but think about it like this. If I have 5 to the third power divided by 5 to the third power, as a shortcut, I could subtract my exponents, and 3 minus 3 would give me 5 to the 0 power. But another way to think about this is 5 to the third power is 5 times 5 times 5, or 125. And down here, 5 to the third power is also 5 times 5 times 5, or 125. And 125 divided by 125 is 1. Anything to the 0 power will equal 1, with one exception. 0 to the 0 power is undefined. When we're talking about negative exponents, any integer to a negative power is the reciprocal of that power to a positive power. So think about it this way. 5 to the third power times 5 to the negative third power. Together, add these up, we'll get 5 to the 0 power, which we now know is 1. We also know that 5 to the third power is 125. In order for me to get a final answer of 1 here, I have to do 125 divided by 125. The only thing I can multiply by here is 1 over 125. That will give me 125 over 125 and equal 1, the answer I know I'm supposed to get, which means 5 to the negative third power is equal to 1 over 125, or 5 to the negative third power is equal to 1 over 5 to the third power. So it's the reciprocal of this power, but now it's to a positive power. So let's try to evaluate some of these expressions. They want us to solve these. Well, when I see a negative power, I don't know exactly what my answer is going to be, but I can change it to a positive power by doing the reciprocal. So instead of attempting to do 3 to the negative fourth power, I'm going to do 1 over 3 to the fourth power. These are equivalent. So 3 times 3 times 3 times 3 is going to give me 81. So this is going to be equal to 1 over 81. In this problem, I've got negative 8.5 to the fourth power times negative 8.5 to, negative 8.5 to the negative fourth power times negative 8.5 to the fourth power. So since these have the same base and I'm multiplying them, to combine them, I'm going to first add their exponents, which gives me negative 8.5 to the 0 power. Well, anything that's not 0 to the 0 power equals 1. In this case, I'm dividing, so I'm going to subtract my exponents as a shortcut. It's the exponent of my numerator minus the exponent of my denominator, which gives me 2 to the negative second power. When I see a negative power, I'm not going to be able to solve that, but I can do its equivalent, the reciprocal, and now the power can become positive. So 1 over 2 to the second power, well, 2 to the second power is 4, so I get 1/4. Let's try a few more here. They're asking us to simplify here and write our expression using only positive exponents. Well, in this case, I have 5 times x to the 0 power. Well, assuming that x is not 0, I would have x to the 0 power as equal to 1. So I'd have 5 times 1, or 5 for my answer here. On this one, I see that I have a number in the top, but not in the bottom. I can add in a ghost 1 here. And I'm going to separate these two. So I'm going to have 9 over 1 times y to the negative third over y to the fifth. And I'm going to simplify from here. So 9 divided by 1 gives me 9. And for this one, I'm going to subtract my exponents. It's always the numerator exponent minus the denominator. So I get 9 times y to the negative 8th power. Well, I'm not allowed to leave any of my powers as negative powers. So this is really going to be 9 times, and if I do the reciprocal here, 1 over y to the 8th power. When I do the reciprocal, the power becomes positive. So now on the top, I have 9 times 1 is 9 over y to the 8th power. So finally, our real life application. A drop of water leaks from a faucet every second. How many liters of water leak from the faucet in 1 hour? Okay, a drop of water is equivalent to 50 to the negative second power liter. All right, so I know that this is a drop of water, and we know that they leak from the faucet every second, one of these drops, and they want to know how much leaks in an hour. So if this happens every second, there's 60 seconds in a minute. So if I multiply by 60, that's how much water is leaking in a minute. And then there are 60 minutes in an hour. So if I multiply by 60 again, I'm going to have how much water leaks out in 1 hour. So I'm going to combine these now. In order to do that, I first need to make this a positive exponent. So I can do 1 over 50 to the second power, which gives me 1 over 2,500. I'm going to turn these 60s into fractions too by putting a 1 under them. So I can do 1 times 60 on top, and I get 3,600. 2,500 times 1 on the bottom, I get 2,500. And if I divide these, I get 1.44 liters of water leaking out of this faucet per hour.